Yes. We'll try to have 2 lectures in one today, so that will be quite fast when I go through everything. If we still have something left in the end of the lecture, I will catch up there when we start the next lecture, which I hope. I think it's the next time Rune comes to give you a lecture on, let's see, on semantic web. Let's see, no, I'm not. Let's look at the schedule here so that I'm sure. Yes. Next Monday, there will be a lecture as well. So you have to remember that. Look at the time and see the schedule. Because of a ski day, the lecture was moved from Thursday to Monday. I think you got a message on that. Okay. And Rune will have that lecture. So there's a minor mistake in the front room, I see, because week 7 it says social web and mobile web. This lecture will be held in week 8, not 7. So I will switch those. Okay, but today's or last time's lecture was service-oriented architectures part 2. But unfortunately I couldn't make it then. So we'll start with the part 2 of service-oriented architectures today. And we'll move on to web applications and go as long as we can on that topic as we go along. Okay? Yes. And you also have to remember the assignment that is due 15th of February. You see the dates in front there.
About the assignment, can we discuss it because of now or in the end?
We can take questions on assignments in between my sessions. I'll take questions for that. Okay. So we'll start with the lecture now. Okay, topics for today: RESTful services, the characteristics of REST, and REST examples. The 2 lectures that we are going through today is 2 of the most interesting in this course, I will have to say, because you will see a lot of features in the web, in the web browser. A lot of the specifications that were talked on and discussed related to HTML5, and a lot of the APIs that you have available now in JavaScript that you didn't have available, that weren't available before. And in this service-oriented lecture, I will talk to you about RESTful services, which are maybe the most common services that today, because web services was more or less the standards that those implementing services used for a lot of years, but now the trend is that we're going for RESTful services. You see that for all of the major companies and software vendors like LinkedIn and Facebook and Twitter. They all provide RESTful APIs. Some of them provided web services before and still do, but they have also provided RESTful APIs. And as a developer, I have to say that it's much easier to implement something when you have a RESTful API rather than a web service. It's a lot easier to get started with the API. So let's look into the RESTful services. We'll look into characteristics of REST and REST examples. I'll give you some examples of how you build these services, how you should structure them, and you will look into a general idea of developing services, what we have to think about when we develop services, like processes and composition and quality of service. Okay. If you read the literature for last time, you maybe know what RESTful means, or REST means. It's 10 points, those known. Representational
State transfer.
Yeah, exactly. So what is that? RESTful web services are based on an architectural style REST, as developed and described by Roy Fielding. Roy Fielding did a doctoral dissertation on RESTful web services. At that time, it was employed by Apache and worked with the Apache web server, so we had a lot of knowledge on the HTTP protocol and how this works, and how web servers works, and so on and so on. So, but we have to remember that this is an architectural style. It's not a standard. It's more or less conventions of how you should build your web service. And if you build it upon HTTP, how can you use utilize HTTP and build your web service based on the paradigms that you already have in HTTP? So what does representational state transfer mean? The architecture style REST consists of a set of constraints applied to elements within the architecture. REST also consists of guidelines and best practices related to web services based on the original web architecture. When we talk about the web architecture, we talk about the standards that the web is based on. HTTP is one major component there. Okay, so what are the characteristics and constraints of REST? First of all, it's an entirely client-server communication type. You have a uniform interface which separates the client from the server. What is the interface? It's the commands that you have in HTTP. Get, post, patch, put, delete. Mostly. You also have others. You want to ensure statelessness. Independent requests, each request must contain all information necessary. don't want your client to maintain some kind of state which may be determines how an object should be constructed or built. You want to have statelessness. If I do a GET request with the same headers to one resource, I should at any time of the day, in any context, I should get the same object back. Unless it has changed on the server in some time, I should get the same object. Maybe with different values, but the same object. If we had a universal ID on that object, it should be the same ID. One type of stateless or statefulness is what we talked about in the first lecture, I think. You remember this? We talked about client. Client sniffing on the server side, where a server sniffs on what kind of client is requesting a resource. You remember that? If it's a Chrome browser or a Firefox browser or something like that, if the server returns different kind of objects based on what kind of client is requesting the object, then you have statefulness. The state of the object depends on the client's context. Okay, you also have the potential usage of caching in REST. Responses are cacheable to increase network efficiency. Do you know any caching servers or something like that?
Varnish.
Yeah, Varnish. You can also use Nginx as a caching server and as a web server. That is a typical intermediary. You have your web server, you have an intermediary, and you have a client. The client is requesting the intermediary, the caching server. The caching server is asking for the objects from the web server and gets the object back, caches it, and responds to the client. If another client asks for the same object, based on some constraints on the caching server, it returns the same object without asking the web server. You see? In that way, you're increasing network efficiency and you're lowering the demand on your web server. You can also have load balancing by setting maybe 3 caching servers or 2 caching servers in front of maybe 5 web servers. That is interlinked and uses the same database. In this way, you're increasing the efficiency of your web system. So caching is a bit is also a characteristic of REST. Okay, what is a uniform interface? All resources accessed through an interface based on following constraints. You want an identification of resources. We'll come back to how we identify resources in REST. You want to be able to manipulate resources through their representation. You want self-descriptive messages, and you're using hypermedia or hypertext as the engine of application state. And you also have layered components in their REST architecture. Intermediaries like proxy servers, cache servers, etc. can be inserted to improve scalability and performance, like load balancing, like caching, and so on. You can also have code on demand in REST services. It's not that common. Maybe, have you heard of JSONP? No, yeah, JSONP. It's requests to a server that returns an object wrapped in a JavaScript function, in a JavaScript method, so that you can run this method on your client and then maybe do some manipulation on that. It's not directly related to code on demand and on REST, but in the theory, in the dissertation of Fielding, he described this code on demand. You can provide code to the client to describe how you should act upon on the object. So optionally, clients can be extended dynamically by servers providing executable code. There are, of course, some security issues related to this. Okay, well, what kind of elements do we have in a REST architecture? REST style is an abstraction of architectural elements within a distributed hypermedia system. The data elements that you have. A resource, that's the target of a hypertext reference. What is a hypertext reference? If a client asks for a resource, it does a hypertext reference and asks for that resource. Why? Based on the recurrence, typically a URL or something. When you ask for the resource, you use a resource identifier, URL. The object could be represented in different encodings, different formats. Like it could be represented as an HTML document, it could be a JPEG image, it could be a JSON object, and an XML document or anything. And you can also provide representation metadata. Typically you provide that in your HTTP headers, like the media type, last modified time. The client can provide resource metadata. For example, with the vary header, it can say to the server what kind of the server can provide resource metadata to a caching server. For example, with the vary header, it can say that this object depends on other headers in your HTTP header. So if you cache this object, it should be differently with this header than with this header. So it should be wary on this specific HTTP header. You can also provide control data, if modified sins, and cache control to the client to ensure that the client caches this object. Other elements in the REST architectural style. We talk about connectors. For example, a web browser is using a connector whenever it asks for a resource. So you can think of the connector as an intermediary. Typically, connectors, you have a client connector and a server connector, which can talk together, resolver, tunnels, etc. And in REST architecture, we also have what we call components in this kind of architecture. That can be the web browser, for example. That's a component. The component is using a connector and connects to another connector, which is used by another component. You see? So a web server like Apache or something is a component using maybe a connector, an endpoint, you can say, which connects to the client connector, and the connector of the client is used by the web browser, which also is a component. You can also have intermediary components, as I already talked about, like caching servers, proxies, and such. Okay, let's get a little bit more practical, because REST utilizes existing HTTP verbs. We have the commands, HTTP verbs, get, post, put, patch, and delete. Do you remember what was what? Let's get. What does it get? If we get a URL, what should happen?
Resource.
Yeah, we should. The response should contain the resource object, or an HTML document, or a JPEG image, or whatever. Okay. So these are the typical HTTP commands that we use when we browse the web. These are get commands. Okay, post. What should a post do?
We can upload documents or change some data in it.
Yeah.
Modify it.
We'll come back to modify, but it should send data to the server and instantiate an object, you can say. Okay?
Typically,
Yeah, like with a form, HTML form, for example, or an AJAX request with some post data. But how do you utilize put and patch?
put it or insert it.
Put is for
Inserting new data.
updating. Yeah. What about patch?
Adding something that's already there.
Yeah, but also put, you can do that. But typically the difference between put and patch in the REST context is that when you put the entire object. So you update the entire object, you see? But with patch, you're patching some of the variables, for example, of the object, parts of the object. And delete is for deleting objects. Yeah. Okay, so resources objects are identified by URIs. So what's the anatomy of a REST request? It's typically like the anatomy of an HTTP request. You use some kind of verb, get, post, put, or delete. You use the protocol HTTP or HTTPS. You have to have some kind of domain, and the resource collection name and the resource identifier. So if we want to get a resource, the protocol, typically domain.com, for example, you have resources after as the root address and some kind of identifier. We can also have additional steps up here. We'll come back to that for related objects. Okay, so that gives us get http carservice.com/cars/ an identifier of the car, TF 90000. So this is one way of doing REST. You have a collection, that's cars. You have a domain, carservice.com, and you have an identifier, TF90,000. Okay. You can also have REST-like APIs if you have some constraints on your server or something like that. So then you can't enable these kind of routes like we have here. You can also have try to reach resource or scripts directly, cars.cfm or PHP or anything, and provide the ID as a get parameter. That's REST-like, typically. But we prefer the first one. So get for retrieve a resource or object, post, create a resource or object, yes, post, put for update and replacing a resource or object, patch for partially update the resource or object, delete for deleting a resource or object. Okay, on the server side, we can identify the media type of the resource that we're responding with as well, using the media type with content type a HTTP header. So this is an example of application JSON. This is a JSON object that is returned. So how do you return XML resources, for example? We have content type application/XML. And we have to have the content length header. This is the minimal HTTP headers that we can have. And then we return the object itself, encoded as XML. What about the JSON resource? How do you return that? Content type, application JSON, and JSON object. It's quite straightforward whenever you get to know the HTTP protocol and you remember the routes that you typically set up for your object and collections. Okay. Actually, I had a question in one of the lectures. Do you use SOAP upon REST? SOAP 1.1 and 1.2 supports the HTTP binding, which uses HTTP GET. But HTTP GET does not allow a request body, so there can't be any SOAP content in the request. But you can respond SOAP content, but it doesn't make sense. If you build a REST API, base it on a REST architectural guidelines. Okay, if you want to look into REST and WSDL or WSDL, you can go into the link that I provided in these slides. Okay, let's look at some practical REST examples. productservice.com/products. If I do a GET request to this resource, what should I get? Yeah, collection of products. if I also provide a header as a client, an accept header, where I said that I accept JSON, for example, then I should the object should be encoded in JSON, or if I accept XML, it should be encoded in XML. But typically, you don't support all the type of encodings that you have for an object, but the client typically knows this. Okay, if I do a post then to productservice.com/products, what should happen?
If you do a post on that,
It register new product.
Yeah. Correct. If I do a put to productservice.com/products,
it updates the system.
One
Replace
the entire product.
Collection.
Yeah. So you should send a collection of products in a put, and it updates the entire collection. Yes, and should delete the entire collection. So productservice.com/products/112. We can do a get against that URL, of course. If you do a post, what should happen then? Actually, the best way to do this is allow posts only on the collections and not on the actual resource, because a post is for instantiating new objects. You see? So it's not entirely correct that all URIs should support get, post, put, and delete. I have to correct myself there. But you shouldn't do posts against identified resources. But you can do put and patch, for example, to update the object. And delete to delete the object. Let's see, weatherservice.com/regions/543/forecasts. What does this mean then? If I do a get there.
Get forecast from a specific region.
Yeah.
With ID.
So in this way you can also access related objects. You remember relations in your database lectures, I suppose. Typically one-to-many relations like this you can identify with this kind of scheme. Many-to-many relations as well can be identified in this way. One of the directions of the relation. So, what if I have weatherservice.com regions 543 forecasts 2015-8-1? That means, of course, the forecast of that specific date. What if you turn this around and have weatherservice.com/forecasts and a date/regions/ what should you get then? An error, yeah. If it's not a reproducible relation there, you should get an error. But if it's different types of objects with a relation, maybe a man-to-many relation, you can also have the reverse URI scheme available as well. You can also have versioned and namespaced API by using a version number of some kind. And this is a good practice for Because there are a lot of applications that are dependent on the 1.0 version of your API. If you want to update that and you maybe have some breaking changes to the interface, then you should have version 2.0, for example. Typically, you see that in APIs of the big software vendors like LinkedIn and so on. If I do a post with a collection to weatherservice.com/regions/543/forecasts, then should happen. A post with a collection of forecasts.
Assign all those forecasts to that region.
Yeah. And delete the others, the existing ones. Okay, how to map URLs to controller scripts that responds with data. How can we build these URI schemes in an easy way? I suppose you have used some kind of framework for that. Java frameworks, are there easy REST Java frameworks? Like
RESTlet, JaxRS,
exactly. For Python?
Python. Yeah, it was Flask with plugin Flask REST.
Yeah, exactly. Express.js for Node, Send or Cake or Symfony for PHP. .NET?
ASP.NET Web APIs.
Yeah. So these typically provide out-of-the-box routing, configuring routing, so it's easy to set up this kind of REST services. Okay, a REST client example, a JavaScript XML HTTP request object example. It's 5 minutes, so we'll go through these examples and then we'll take a break. If we want to use the pure XML HTTP request object, we'll do something like this. Rect on unready state change. We set a function or handler for this kind of event. And then we do a rec open with a post to our URL that we have defined up here. We set a request header and then we send maybe some kind of form and the form encoded, URL encoded. If we want to do it a little bit easier, we have jQuery wrapped methods for this. And it saves you some lines of code. Or you can use the Angular way with HTTP post, for example, which gives you what is called a promise. So this is the client way of doing requests. I suppose many of you have already tried it. If we should build the routing ourselves on the server without the framework, we can do something like this in PHP, where we explode the URI that we get that is requested, and based on the URI fragments, we try to find out what kind of collection, what kind of resource that is identified, and then we return something based on that. But of course, this is not the best way of doing it. Use frameworks for this. It's much easier. Yes, we'll take a break. 10 minutes. 10 past 2. We'll start again.